Hey, what's up, guys? I am Joe from Workbench, and today we're going to talk a little bit more about L systems, but we're also going to talk about how to move points along a grid in a digital fashion. So today we're going to look at how these L systems are built, but if you want any more in-depth information, you can grab the project file from our website for $1. So a couple of tutorials back, which I'll link below, we basically built sort of a pseudo L system, but this time we're going to do the real thing, at least as far as we can do in After Effects relatively easily. There's pretty complex L systems where there's like really weird replacements, and I'll show you what happens in After Effects with that in a little bit. But first, let's take a look at this pretty simple one. It's actually called a dragon curve, but it kind of reminded me of Flying Nimbus for all you DBZ fans. And so L systems all start basically with a seeded value, which is basically iterated over, and parts of those things are replaced with more complex patterns. And so in this case, we have all of that tied to a controller up here, this guy. And you can see we have iterations to 10. This is kind of an exponential growth, so you got to be very careful with this iteration slider. You will lock up After Effects if you go too much further than 10 in this one, for example. We can go to 11 and maybe 12. It's pushing it. On my laptop, I think this thing crapped out at like 14. Well, actually, that's not true. I tried to do 20. Now, what's interesting is on this one, I don't have it set up. What I'll show you later is a way to calculate how many points we actually have, because that's going to be relevant in how things move later on. But for now, just know that this is a ton of points. I think at 10, it's like 1,000 and something. So let's go back to 10 so that we're a little safe here. And let's open up Expressionist and see how this code is. Some weird redrawing. Probably because there's a lot of points here. So let's bring this back. I think that's it. I don't think there's any calculations at the end of this. We'll scroll if we need to. So we're going to start off like when we normally build ourselves a shape path with an empty array called points. Then we're going to set up our variables so that X and Y start in the middle at 0. This is in the space of the shape, so we don't have to worry about the center of the comp itself. So 0, 0 is the origin. So we want to start by going up. So we're going to make sure that our angle, which we're going to call A here, is set to -90. So command will be basically what they call the axiom generally. I guess I could have called it that, but this actually kind of makes sense in the scope of how we're building this thing, as you'll see in a little bit. So sometimes this will be like A and B, or just A or X or whatever, just however somebody decides to write the actual system. It seems that in most of them, they use F and X and Y. I'm not sure how Cinema does that, because Cinema has an L system thing that you can also build this thing in. You'd have to talk to Sev about that one. You can also look up Turtle Graphics or whatever, and I'll link that as well as the Wikipedia on L systems themselves, because there's a lot of interesting stuff that you can do with these things. So anyway, our next thing is going to be bringing in all of our controllers. So we're going to have iterations set to our controller. So this guy, this iteration is on the controller layer. We're going to have D be the distance that we move every time. And that here is set to 10 for now. So you can see if we make this bigger how that affects it. Let's go back to 10 for now, because I kind of like it compact for this one. It's kind of nice looking. So then we're going to have another controller here called angle. And this angle is actually going to be how much of a change we have depending on the commands that we give our L system. Some of them move in 90-degree increments. Some of them move in 60 or 120. It all depends on whatever you're doing with it. As this is set up, you could actually tweak this thing to like 45 and get something completely different. Or you can go to like 135 and get something really tiny. Terrible. I haven't done that. That's 100. So it's kind of interesting. You can, play with that and see what you get. It's kind of cool. You can unravel it if you animate it. So the next thing, and this is some code I found online, it's actually kind of a nice way to replace stuff when you have more than one thing you need to replace. Because generally when you're replacing these things, you're going to replace two things. And sometimes those things are contained in the other thing. So you have to do them both at the same time versus replacing one and then replacing the other. So we're going to set up an object here for map. So it's going to have open braces. And then we're going to have X:, and then inside of quotes, we have X plus YF plus. And then we close our quotes. We have a comma. We have Y:, quotes, dash FX, dash Y. Close the quotes, close the braces, and that line. And in a moment, I'll explain how that's going to work. So the next thing we're going to do is we're going to set up a for loop, and we're going to set it to var I equals 0, while I is less than our iterations value. We're going to do I++, and then we're going to set our command cmd variable equal to command.replace, and inside here we have a regular expression, and it's just slash capital X with a pipe in between, and then we have Y, and then we slash, and then we have GI. So basically this means we're going to look for all X's or Y's globally and case insensitive, which doesn't really matter because I'm not dealing with user input, so this could just be G instead of GI. It might make it a little bit faster if you dump that off of there. Anyway, then we're going to have a function. This function is going to be fed an X or a Y, and it's going to return the X or the Y from the map object in here. So if it's X, we're actually going to get X plus YF plus back, and that's going to replace the X that we had in there. And if it's Y, it'll replace it with the other piece, and so on. We're going to do that for whatever amount of iterations we have, and then we're going to be left with a very long string. And if I bring this down, because it is very, very long, especially at 10, if we bring this down to 8, you can actually see how that's replaced. And if we bring this down to 1, or 0 even, I think, yeah, so 0, you can see we're back to our original axiom of fx. We go to 1, you can see how they're replaced. So x has now been replaced with x plus yf plus, and so on until we get to 9. Well, we're probably up to a couple thousand characters, maybe. I think at 10 this is 4,000, something like that. And again, be very careful with that, especially if your axioms and your replacements are more complex, because once you get into like super complex replacements, there's one of them here I think that has like 13,000 at 10. So really can get crazy amounts of characters and whatnot fast. So that's going to result in points and different things that happen from what we're going to build next. So we're going to start by pushing to the points array our original x and y, which is 0, 0. So then we're going to have a for loop that's going to loop through all of the characters in our command string. So we're going to do for var I equals 0, while I is less than command.length, I++. And if you're curious about how many things are in this thing, if we actually put in here throw command.length, thanks Matthias, we're going to add this back to here. It's going to give us an error. And if we go into here, it will tell us a number. So you can see 4,094 is how many we have at 10. So if we bring this up to 11 and hit that and click back, I think if we can click it here, it'll tell us, yeah, 8190. That was actually pretty much exponential directly, it looks like. So if we make this 12, you can see then if we click this guy, we are now at 16,382. So every time it doubles. All right, so let's take that out of there. That's one way you can figure out that, but we're going to use that differently later on. Although that is a way that we can tell with pretty good certainty how many things we have. Although I'm really more interested in how many points we're going to have. That's basically how many instructions we'll have, but it's not entirely how many points we'll have because some things are skipped, as you will see very soon. So let's click back here, add this back in, get our Nimbus at 12. I really want to push this more, but I don't want to kill this recording. It's actually already kind of difficult to work with. So I'm going to click on here, put this back to 10, and you can see how slow that is. But now we're back to something workable, so let's keep going. All right, so we're looping through our command string here. And so then we have a switch case. So we're going to switch based on the command.character at car at I. So at whatever position we're at, that character, we're going to look at it. And if it's F, we move forward. And since our angle could be at a different angle than what we started with, we're going to do x plus equals math.cosine, and then I'm going to convert it to radians, so we have degrees to radians A for our angle, and it's going to be multiplied by D, which is our distance between points. Y is the same thing, but instead of cosine, it's sine. And then we're going to add a new point to that array, so we're going to do points.push, and note that these are inside of brackets inside the parentheses for the push function. So we got brackets, x comma y, and then we break so that this loop can continue on to the next thing. If the next one's a plus, we're going to add to the angle. So basically plus means rotating to the right. So we're going to do A, so whatever our angle is currently, plus equals by angle by our amount. So if this is 0 and we're going to go to the right, we're going to add 90 to it. So it'll be 90. And we'll break. And if it's a dash or a minus sign or whatever, then we're just going to do the same thing we just did, except we're going to go to the left. So we're going to do A minus equals angle. And break. And that's that. Then we close out of our switch case and our for loop. And then we do create path. And then we're going to do points. And then we're going to pass in 2 blank arrays because I'm not going to do in tangents or out tangents. But we do want to be able to set this to false instead of true, because otherwise we'll have a line that connects from here to here, and I don't want that. So that's it for that particular L system. So I didn't go through these and standardize these to a different thing. I looked at the Wikipedia article that had these set because it was just easier to not have to think about that. But if you really want to, you could build basically a standard library for these characters so that F is always forward or whatever, because basically the commands are pretty similar amongst them. They just use different things. If one of these used like A and B instead of X and Y or F or whatever, and I just wrote them that way. But it's probably a good idea to standardize them to something so that plus always rotates one way or minus always rotates the other way, and so on. Because the actual commands are pretty similar amongst all of these. So let's look at the next one. You ever seen the Sierpinski Triangle? Well, this is basically the same thing, except for we're done as this one line. So it goes the whole way, all the way around. If you actually ask me the mathematics behind this thing, I have no idea. I just know that if you break up a line like this first one, which this one's going to kind of start all over the place because of how I have it set, but it's going to start here, and then it's going to end more breaks along the line, and you're just going to eventually get there. Every time it rotates more. Oop, don't go too far. That one only needs to be at 6. Every odd one rotates at a different direction. So if you want it to be this direction, it needs to be an even number. So if I hit EE on this guy real quick, we'll get this path, and we'll bring that in. And you can see it's pretty similar. Our replacements are different, and our start angle is different. That's just to get this thing kind of going in the right direction. In this case, too, you can see here that B and A technically do the same thing. So switch cases are kind of interesting because pretty much once one of these things evaluates to true, it will just keep going until it reaches a break statement. So basically, B has nothing here, but it will do what A does because there's no break in between. So it'll keep going, do this stuff, and then break. So this is one reason why I didn't really standardize everything in here, because in this case, B and A both do what F did in the previous one, but in this case, you need both the A and the B to replace different things. So there's probably a way to work it out so that it works in the other format, and so you can have more of a standardized little switch statement here that will work for everything, but you'd have to figure it out, and I was lazy. So let's go on to the next one. So the next one was supposed to be pretty interesting, and I'll pop this code in for anyone who wants to look at it while we're talking about it, but the code itself will actually be on our website if you want to grab it off of there. So this one's a little bit more complicated, and this is kind of one that doesn't really work in After Effects. It's supposed to look like this, so you can see like it branches and does that, which I really didn't expect to work out, but I just kind of wanted to see what would happen. And what we got was kind of interesting. Some cauliflower or something like that. Or like a contour drawing or something like that, where you don't pick up your pencil in between the things. You can kind of see how things kind of were supposed to break and go back, because that's what's supposed to happen here. It's supposed to be that when we come to this bracket, we basically save all of the information about the point that we're at currently, so that when we reach an end bracket, we will return there. So basically you can make a branch from another part, but it's kind of hard to do that in After Effects because you're making one path. You can't make multiple ones in one particular expression, so that kind of kills it. So other than that, it's pretty much the same thing. It just doesn't work. All right, moving on. So now let's kind of lead into what kind of led me into building this. I was working on a project that I needed kind of a gridded movement thing. So for that, all I did was take what we had previously built, and I made sure to standardize all the distances between everything instead of having random distances so that it became a grid. But now I kind of wanted to see what that looked like if we took a grid that was basically kind of like this fractal thing. So if we bring this path expression open in here, you can see it's the same code because this isn't really what we're changing. So we still have to build that path. It still is going to take whatever time it takes. However, we don't really need to go so many iterations because we really don't need that many points to make this movement work. So what we're doing here is we're basically figuring out how many points we have. So if we bring the thing in here, we can pop this guy up. You can see that we're setting a points variable equal to this comp layer shape, content, path 1, path points. Basically, I pick up the path, put it in there, added dot points with some parentheses at the end of that, and then started a string of points with a colon, a space, close that guy off, added a plus, and then we just put points.length. You could just put points.length if you want, either way, and just call it a day. So now we know we have 257 points in whichever shape this is. They're all the same thing, but I think that's this one at the bottom here. So if we add more with this, you can see we're going to add way more points. 513. I'm not going to go too high on this one because I have 4 copies of this. They're all rotated 90 degrees from each other. So they're going to move like this, which is pretty neat. One thing you could do is basically draw a shape that follows all of these things. So you'd have like a square that moves in kind of an interesting pattern, almost like a weird digital eye or something. But these points are cool enough on their own, so I just kind of left them that way. I didn't want to go nuts. So basically all we're doing here is we are taking our endpoint of a trim paths thing here, and I'm going to bring this guy up over here. And then we have some keys in here, and they're basically keyframed from 0 to 100 divided by 257. because we need to fit 257 points in 100%. And the last keyframe is the same as the second one so that it holds. And then we're going to do loopOut offset. I actually saw this on Twitter recently. I don't remember who posted it, unfortunately, but I had seen this one in docs before. I never really read what it did or anything. I just assumed kind of what it did, I guess, but never really thought about how to use it. But basically, we have this set up so that it basically moves one line across here, and then it holds for a little bit of time. And what happens with this loop out is that it basically repeats this thing, but starting at this last value. So what happens is that we go through our keys, and at the end here, this starts over again, but instead of restarting from this point, these keys are then added to the value at the end. So once we move down one way, it will then move down the next part, and then the next part, and then the next part, all the way around. So the start is going to look at the end, and then just subtract 0.001, and that's just so we have the smallest of paths. So then all you gotta do is make sure that your stroke has a butt cap, or projecting cap, I think is what they call it in After Effects, or round, just anything that's not just the default of having nothing, and you will have a box or a circle at that point. So you do that, duplicate it around, and then you have yourself an interesting animation. So if you want to build anything complex with this, I would basically take this and pre-comp it so that you're not calculating this thing over and over again, and then you can rotate them or move them around. If it gets really complex, you could pretty much pre-render it and then use it in the same fashion, and it should be a whole lot faster. And for those of you who always ask how we do the thumbnails, and if you're a patron, it might just be in the BTS. Steve. This guy is basically the triangle from before, just here at the bottom. I threw the dots on here. I didn't actually animate them. I will for the GIF for this thing, but I didn't yet. I put in one of my overlay videos that I shot of a prism or whatever. I can't remember what this one was in particular. And I added that over top. I put some glow on. I'm using Boris's Sapphire Glow because it's pretty awesome. And I have that doubled up. I have a wider, more general glow and then a smaller glow. So if we turn this thing off, you can see that it kind of hits that. That one is more overall of everything. I have a textured background in the back that has a little bit of a kind of cloudy, chalky dust kind of thing going on with it. So that's kind of glowing as well. Over top of that, then we have Red Giant Universe's Chromatic Aberration, which I really love. That thing is pretty sweet. And then above that, we have a color correction layer using our Aglow LUT from our LUT pack. All right, so that's pretty much it. I hope you guys can find something cool to use this on. Anyway, if you have any comments or questions, leave them in the comments down below. And if you like this video, make sure to subscribe. If you'd like to help support what we do, check out patreon.com/workbench. Make sure to keep up with the blog at workbench.tv. And as always, I'm Joe, and we'll see you next time. Bye.